My name is Dietrich Kastens. I farm in northwest Kansas with my father and my uncle. We're 100% no-till on primarily silt loam soils that range from flat to some pretty good steepness. We grow wheat, corn, grain sorghum, alfalfa, peas, and soybeans. We've been a continuous no-till for about 10 years now. We've been incorporating no-till for about 20 years, a little over 20 years now. One of the challenges that we face here, of course, is we're in western Kansas, very dry, very hot, very low humidity, lots of evaporation, as you can expect. Residue is king. So we try to spend a lot of time managing residue, including the use of a stripper head for our wheat harvest to leave as much standing residue as we can, and then we'll go back in and plant corn back into that rotation. The corn then is typically followed by grain sorghum or soybeans, which then are followed by either peas or kim fallow or wheat directly. A lot of experimentation with rotations out here, trying to find what works from a residue standpoint and to deal with our limited water resources. Our planting equipment has had to be fine-tuned over the years to deal with higher and higher residue, especially planting into 60 to 70 bushel an acre stripped wheat straw, or 180 plus bushel, 200 bushel an acre irrigated corn stalks. Going no-till involves more and more residue management. That residue is worth its weight in gold, so we do everything we can to not destroy it or completely remove it, but try to work within the system. Part of that is with our grain drills, which we plant the wheat, the peas, and sometimes the grain sorghum with. They're not necessarily heavily modified, although we have incorporated Thompson T-wheels on those drills, as they do a far superior job in closing the seed slot in anything but bare soil. My bias is that any planting equipment that is running in a lot of residue needs to have some sort of a closing wheel system, a spoke closing wheel. We use the Thompson wheels on both the drill and the planter because we feel that those have worked better than what else we've seen in the marketplace. We'll look here specifically at our corn planter, one of our planters. This is a corn planter that we use for our limited irrigation pivots, planting into corn stalks. We do not use this planter typically into heavy wheat stubble, and you'll understand that in a minute. We'll start right up here in the front where we run the Martin 1360 closing system with the depth bands. This has been a very good system for us. We do not run the rolling coulter inside of it. Just trying to move some residue in the limited irrigation, the full irrigation circles. That has worked very well for moving corn stalks and other debris out of the road. Doesn't work so well with the stripped wheat, which often is 30-inch plus size pieces of residue, and it tends to have some issues in that. Moving back from that, you can also see pneumatic down pressure, which is a key feature for all no-till and to any residue at all. Standard John Deere opener, although you can see the backside here of our SeedSense 2020, one of our modules here. We run SeedSense 2020 monitors and systems from Precision Planting on both of our planters, and are excited to see a lot of the things that they're going to be bringing to the table. As we move back here, we run the RK gauge wheel kits. I've just found that those work far superior in the field in keeping this gauge wheel perfectly against this disc. Where that really becomes important are the years when we're a little bit wet or a little bit muddy, trying to keep junk out from inside of the gauge wheel. As the seed goes down, we're using Keaton seed firmers with the Mojo wires. Again, seed placement in my opinion, is key, and that's where residue makes it a challenge to perform. And so the Keaton, along with the Mojo, really does a nice job in ensuring that the seed is placed firmly in the bottom of the trench. The big reason we went with the Mojo wires was not only the extra down pressure, but we found that extra down pressure actually keeps the Keaton in the ground, and so we no longer have the mud build up along the sides that used to plague the non-Mojo Keatons that we've used in the past. That mud that you'd have to clean off, otherwise the Keaton actually rides above the bottom of the seed slot. The downside to that is your ketons will wear out a lot faster, but that's because they're actually doing their job and not floating in space. On the back side of the planter, we're again using the Thompson T wheels. Again, been very pleased with these T wheels. They do a fantastic job in our extreme conditions where we can often be running in sticky, squishy mud all the way to completely baked hard, where I've got these planters running at almost full down pressure. Very pleased with how those have performed for us. Besides that, you can also see here we're running starter fertilizer back down through our keton right into our seed furrow. This typically is a blended product with nitrogen, phosphorus, sulfur, zinc, and we do put some potassium as well, even though we're in very calcareic soils and have very, very high native K rates in our soils. We have a lot of questions with high residue no-till and the fact that it holds the ground temperatures low for so long in the spring about potassium uptake questions. Even though we have a lot, it may not be available when the plant needs it. Hence, we're doing experimentation trying to bring that into the loop. Very standard fertilizer system, just 2 electric pumps on that. With this particular planter, everything is mapped. A lot of hybrid analysis is done as well. Some of the things that I'm are very excited about are moving more towards individual row control of down pressure. That is one of our biggest challenges out here, is that we don't see a lot of down pressure differences or needs within a field because our fields are largely homogeneous in the same silt loam soil type. But what we see is that we see a row opener that happens to be running in a sprayer track or a combine track might need up to 200 pounds more down pressure than the 2 rows around it. And that's very challenging to overcome today, because it means we either have to overload the planter so much with down pressure that we might have 200 to 300 extra pounds on every row, but the row's running in the wheel track, or we optimize the down pressure for the rest of the planter, which means we probably are a little bit shallow planting that seed in the wheel tracks themselves. This is a challenge we're overcoming. Hopefully technology will allow us to overcome that a little easier. I'd like to think that maybe we could not have the wheel tracks, but that's just a very difficult thing to try to accomplish in our particular area. And Kelly, I think with that, maybe we should wrap up a little bit. What do you think I'm missing yet? I'd say the only thing I haven't mentioned is that we are fully section control. This particular planter is individual row on the openers, or third of a planter. This happens to be a 12 row, so every 4 rows on fertilizer, accomplished with some ball valve shutoffs underneath the tank there. Tremendous machine savings with section control technology in our area. We're in an area that is not dominated by flat square quarters. We're heavily terraced. Our fields usually are contained on one side by a road and the other sides by pasture, so very few square edges. And this technology, the section control technology, has really allowed us to run a lot more efficiently the past few years. Another thing I will say on planting technologies, you can see here, weights. You know, you can set the planter for what down pressure you think it's getting, but unless you've got the physical weight on the planter, there's not that weight to be transferred. I think in conjunction, though, with just throwing more weights on, is having the SeedSense 2020 system, which actually gives you a good feel for what is sufficient or not sufficient weight. When we put that system on, my first observation is that it really surprised me the additional down pressure I needed from field to field based on what my internal bias was before we knew what we needed. Always thinking that we were running plenty of down pressure when in fact in some fields we were actually short, and I would have not made that same observation before we actually had the numbers.